Hello students, good morning. Welcome to my lecture for class 12 science subject chemistry, Maharashtra State Board New Syllabus 2020. In the previous lectures, we have started very interesting chapter from inorganic chemistry, that is chapter number 8, transition and inner transition elements. In the previous lectures, we have studied about the meaning of transition elements and inner transition elements. We have studied only meanings. Then we have also studied about position of d block elements in the modern periodic table. We also studied about how to write electronic configuration for different elements. We also studied about abnormal electronic configuration of copper and chromium. Now today we are going to study 4 series of d block elements. First, we will start with general electronic configuration. Electronic configuration of 4 series of d block element. 4 series of d block elements. First transition series is what? 3D series. Second, 4D series. Third, 5D series. And fourth, 6D series. For this, electronic configuration can be written as, put here you get what? Argon. For that atomic number is what? 18. And here you get 3D 1 to 10, 4S 1 to 2. For 4D series, here you get what? Krypton 4D 1 to 10, 5S 1 to 2. 5D, here you have xenon 5D 1 to 10, 6S 1 to 2. And for 6D series, put red on here. Here you get 6D 1 to 10, 7S 1 to 2. So this is the general electronic configuration of 3D series. It is also called as what? It is also called as first transition series. It is first transition series. This is second transition series. And finding is what? Third transition series. Third transition series. And 6D series means fourth transition series. But we are interested in 3D series. So let us start with electronic configuration of 3D series elements. First, put elements. In the second column, you must write down symbol, then atomic number, next column is of expected electronic configuration. And last column is of observed or actual electronic configuration. you know that in 3D series, first element is what? Scandium. First we make columns. Scandium 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now first is what? Scandium. For this symbol is Sc. Atomic number 21. Expected electronic configuration can be written as Ar, and you know that last electron enters d orbital, so it becomes 3d1 and 4s2. For scandium, observed electron configuration is also same, but we will write down observed electron configuration afterwards. Now see the second element, that is what? Titanium. For titanium, the atomic number is 22 and its symbol is Ti. For this, I have written Ar, argon. You know that again here it is 4s2. Last electron enters d subshell, so it becomes 32. Now next vanadium. Next element vanadium, symbol V, atomic number 23. Here first I write argon. Here you know that 4s2, and here it becomes 3d3. See the fourth one, that is what? Chromium. For chromium, symbol is what? Cr, atomic number 24. First you write down argon, then you put 3d. Here you know that 4s2. Here last electron enters d subshell, so it becomes 3d4. 5. Manganese. Symbol is Mn. Atomic number 25. Again put argon. Here you have 4s2. It becomes 3d5. 6. Iron. Symbol is what? Fe. Atomic number 26. Argon. It becomes 3d. Here 4s2, so it becomes 3d6. 7. Is cobalt. Co. Atomic number 27. Here we have argon 3d. We have put 4s2, so 1820. We have 3d7. Next one is what? Nickel. Symbol Ni. Atomic number 28. Here we have argon. It becomes 3d8 because last electron plus d subshell. 9th, copper. Cu. 29. Here we have argon 3d9, 4s2, and last one zinc. Zn, symbol atomic number 30. We have argon 3d10, 4s2. Now see all these 3d orbitals. Last electron enters 3d orbital from 1 to 10. Now see chromium. Already we have studied about this. And see the copper. Here we have some difference because they show abnormal electronic configuration. Ar 3d1, 4s2. No change for scandium, titanium and vanadium. 3d3, 4s2. But we have observed a change. Here what happens, the energy difference between 3D and 4s is very less, and therefore we have AR 3D becomes 3D 5 because one of the electron enters 3D subshell, so it becomes 3D 5, and here one electron is remaining, so it is 4s1. Now again, for manganese, iron and cobalt and nickel, it is opposite electronic configuration is same. So if we have AR 3D 4s2, AR 3D 3D6 4s2, argon 3D7 4s2, argon 3D8 4s2. Now see the copper. Here what happens, we have AR, one of the electron from 4s enters 3D orbital to provide extra stability, so it becomes 3D 10 and 4s1. And last element, zinc, that is AR 3D 10 4s2. Now see, for chromium, here 3D5, and here for copper it is 3D10. That means what? They are stable. The extra stability is provided due to what? Half filled d orbital, and for copper extra stability is provided by completely filled d orbital. I hope you understood elements in the ionic form. I have one question. See this. Write electronic configuration of Fe plus 2 and Fe plus 3. This is my first question. And my second question is what? Why is Fe3 plus more stable than Fe plus 2? There are my two questions. Now see the solution. In this, first write down electronic configuration of Fe. For that, atomic number is what? 26. That means it contains 26 electrons. It can be written as argon 3D, here 4s2. You know that argon 18 to 20, and here you get 3D 6. So in order to write down electronic configuration of Fe2 plus, here we have to remove 2 electrons. First we write down 3d6 4s2. So you remove these electrons, it becomes 4s2. Or for that, you remember one trick. Whatever charge is given, you have to subtract from atomic number of that particular element. So here you get what? 26 minus 2 means 24. Argon carries 18 electrons and 3d6, so 24. So electronic configuration of Fe2 plus can be written as Ar3d6. Similarly, electronic configuration of Fe3 plus can be written as C. 26 minus 3. We have what? How many electrons? 23. So put Ar 18, and here it becomes 3d5. Here, but for this, it is what? Incompletely filled d subshell, but here Fe having 3d5, so it is what? Half filled, and therefore it is more stable. in Fe2 plus 3D subshell is incompletely filled. But in Fe plus 3D subshell is half filled, which provide extra stability to Fe3 plus, and therefore Fe3 plus is more stable than Fe2 plus. So you remember one thing: if D subshell is empty, if it is half filled, and if it is completely filled, then the corresponding ion or element, they are what? More stable. This is about what? Electronic configuration of ions. Oxidation states of first transition series, and you know that first transition series means 3D series. Now see elements 2. Now see the elements belonging to first transition series shows variable oxidation states. So that is what variable oxidation state, because of their general electronic configuration. Now come to oxidation state of first transition series elements. First we consider scandium. Here 3D1 4s2. First see, in the last subshell 4s, see 4s, all these 4s subshell contains 2 electrons. So here +2 oxidation state is common for all the elements. Here +2, +2, +2. For chromium it must be +1, +2 is common. I will explain afterwards. Here +2, +2, +2, +1, +2, +2. See, for all these elements +2 oxidation state is common. Now come to higher oxidation state. See, +2 is what? Lower oxidation state. Exception is what? Chromium and for copper. That will explain afterwards. Now first come to scandium. 3D1 4s2. Because see, when 2 electrons from 4s orbital are loose, then we get +2 oxidation state, and ion form is what? Scandium +2. If one electron from the 3D subshell is lost, then you get +3 oxidation state, and scandium becomes Sc3 plus, and it is more stable. Why? Because here you get what? 3D 0, and therefore it provides extra stability to scandium, means tripositive scandium ion. Tripositive means what? Having +3 oxidation state, and C, it is divalent or dipositive, so it is more stable. Now come to titanium. Lower oxidation state, that is +2. For higher oxidation state, one of the electron is removed from 3D, and so it becomes +3. One more electron is removed from 3D, so it becomes +4. In +4 means titanium can form ions like Ti +2, titanium +3, and titanium +4. Here titanium plus 4 is more stable because it provides extra stability because of d empty orbital. Now similarly here we have plus 3, plus 4 and plus 5. Now see, for chromium the electron concentration is 3d5 4s1. So low oxidation state is what? 1, because only one electron is removed from 4s substrate, so it becomes plus 1. And see, there are 3d5, d5 means what? They contain 5 unpaired electron. So I am showing this 1 2 3 4 5, 1 2 3 4 5. One of the electron is removed from this 3d5, so it becomes plus 2. Again one more electron is removed, so it becomes plus 3. Remove one more electron, so it becomes plus 4. Remove one more electron, so it becomes plus 5. Remove one more electron, so it becomes plus 6. Now for this again same thing, plus 3 plus 4 plus 5 plus 6 and plus 7. It is plus 7. C means maximum oxidation state acquired by manganese in first transition series. Remember that, plus 7. Now what happens next? Again see, 1 2 3 4 5. How many electrons are present? 6. 1 2 3 4 5 6. Now here what happens? We have plus 2. Remove one electron, so it becomes plus 3. Remove one more electron, it becomes plus 4. Remove one more electron, so it becomes plus 5. And remove one more electron, so it becomes plus 6. Now these electrons, they are paired, so they cannot be removed from an atom. So here you get what? Only up to plus 6 oxidation state. Similarly for 7, for copper again same thing happen. 1 2 3 1 2 3 4 5 1 2 3 4 5 6 7. Again remove one electron, you get plus 3. Remove one more electron, you get plus 4. Remove one more electron, you get plus 5. Now rub this. Come to this nickel. 1 2 3 4 5 1 2 3 4 5 6 7 8. So 3d8. Now what happens here? Remove one electron, you get plus 3. Remove one more electron, you get plus 4. Now come to 3d10. Here copper can show two types of electronic configuration. One, two, three, 4, 5. 1, 6, 7, 8, 9, 10. So all are paired. Here you get what? Plus 1. But it can show 3d9 4s2 and therefore it possesses plus 2 also. Similarly for this, CD10 means all the electrons are paired and therefore they show only plus 2 oxidation. Zinc can show only plus 2 oxidation state. This is about what? Oxidation states. See what happens here. Here oxidation state increases from scandium to manganese, because in this case number of unpaired electrons are increases and therefore oxidation state increases up to +7. But afterwards, what happens? From iron to zinc, number of unpaired electrons goes on decreasing and therefore oxidation state goes on decreasing. I hope you understood both the concept, that is electronic configuration of first transition series and oxidation state of first transition series. Thank you very much. Enjoy.